In this particular video, we're going to look at Unit 4 Physics, IAL, Edexcel. So this is the concept of capacitance. We're going to see how you're supposed to approach different questions that have been asked in previous years. And then we get to see how do you maximize the marks and how do you maximize the approach in order to attain that particular mark that you want to attain. So if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And also, if you are not joined our Patreon page, consider checking the description so that you can be able to access the PDF of these papers that I'm sharing at this given point. Without much ado, I would like to take you straight so that we can be able to have a discussion on what is expected in this particular tutorial. So here we are told that a student builds the circuit shown. The capacitor was initially uncharged, and then we can be able to see it's connected in such a way that is series with the rest. We have the source of PD, and then we have the capacitor at this given point. And then we are supposed to answer a question. Then she closed the switch and plotted the graph of current on the ammeter A1 against time. So what are we supposed to do in order to determine the initial value of the current? We are told that determine whether the initial value of the current of the graph is consistent with the value on the diagram. So in this particular part, you realize that we are going to use the formula current is equals to V over R, whereby V is the voltage, which is 0.5, and then the resistance that we are having here is 33 kilo ohms. So which means that at that point of time, we are supposed to ideally try to work out so that we can be able to check the value. If you use the values that we are having on the graph, is it going to be an equivalent to the value that is showed on the graph here, right? So if you do the calculation, you're going to get this is going to be 0.15 milliamperes. And if you look at the graph, you can see the value that is indicated there is 0.15 milliamperes. So meaning that this value that we have, the initial value of the current on the graph, is consistent to the value stated on the circuit diagram. We are supposed to explain how the current in ammeter 2 will vary over time. Explain how the current on ammeter 2 will vary over the same time. So we are going to realize that since this is a series current circuit, we shall say that current will vary with time in the same way as ammeter 1, because all these ammeter 1 and ammeter 2 are in the series circuit. So they are going to vary the same way because current is the same everywhere in the series circuit. Next part is where candidates are expected to determine the capacitance of the capacitor. And in order for you to determine the capacitance of the capacitor, in this case, you can be able to identify a point whereby you can be able to read the current and the corresponding time for that. And for that case, you can see here, I identified this particular point that is here. I identified this point. So I read the current, this point, and also I read the time down there. And those two values, I used them in the formula ln of I is equal to ln of the initial current, which was this current here. And then when I substituted here, I was able to work out the value of C, because capacitance is C, and the time already we have it as 3 seconds, and then we have the resistance, which is well stated here. So if you work it out, you are going to get the capacitance to be 2.24 times 10 raised to the power negative 4 farads. We are supposed also to determine the charge stored in the capacitor in the 30 seconds. So what you are supposed to remember is that charge is equals to capacitance times voltage, and in that case our capacitance, we have gotten it here. So we are supposed now to use the voltage that we are having at this point in order to work it out, and you'll get it to be equivalent to 1.1 times 10 raised to the power negative 3 coulombs. If you are asked to determine the maximum energy stored, you need to remember that energy stored is the same as the work done. Energy stored can be given by the formula a half QV, charge times voltage. It can be given as a half capacitance times voltage squared, or you can also work it using the formula a half Q squared C. So those are the possible formulas that you have in your disposal in order to work out that capacitance in that case, the energy stored, maximum energy stored. And then we shall have it in mind that we are going to use the concept of W is equal, or the work done or the charge stored is maximum charge stored is going to be equals to a half CV squared. So in this case, I used the concept of which formula did I use here? I used the formula charge is equals to a half QV. So charge already, we have it in this part, and then I multiplied the voltage in order to get the maximum charge stored. I would like also to bring to your attention that in the event you are asked to work out the charge stored in the capacitor 30 seconds, you are going to work out the area under the graph. You shall focus on working out the area. In order to find alternatively the charge stored, whenever you have a question like this, you can be able to work out the area under this graph. So if you manage to work out the area under this graph, you'll be able to work out the amount of charge stored. So those are a few things that you must master in order to maximize in this particular paper 4. A student investigates that. So moving to the next question here, we are told that so we are told a student investigated the charging capacitance. She measured the current in the capacitor circuit as shown there. Add the diagram to show the suitable circuit for measuring the current and the capacitor charged. So basically that is another set of questions that we need to look at, and the part that was given here is this section that we have here. There was a resistor and there was a capacitor. So in order for us to measure the current, we are going to have a cell which is going to act as a source of PD, and then we shall have our ammeter in series. So and the resistor, then we're done like that. The resistance of the resistor is 5.1 kilo ohms. We're supposed to show that the capacitance of the capacitor is about 0.0 microfarads. And in this case, we are going to just identify a point on the graph. You measure the corresponding time, and on the other side, you are going to measure the corresponding current. So in that way, we are going to use this particular equation. And remember, whenever you are having this equation like this, you can be able to introduce logarithm so that you can be able to remove the exponent from this particular part. Remember, the purpose is to find the capacitance, and the capacitance is the value of C that we are having here. So if you are going to introduce natural logs here, you have ln of I current, that is the current that is remaining, to the ln of the original current, and the original current is this current, or current naught is this current that is when time is 0. Okay, and having that, we can be able to say ln of E is going to be T of ln of RC. So taking this on the other side and rearranging this equation, we are going to have C as T over R into ln of I naught minus ln I. After rearranging the equation that we were having there, this is exactly what we are going to have at that given point. So meaning that we need to substitute time is 100 seconds and current is 0.8 and I naught is 2.4, remembering that 2.4 is basically milliamperes. Most of the time students multiply values that you have on this axis by 10 raised power negative 3 so that you are going to maximize on your mark. So if you work it out, you are going to get your answer as 0.0178, which is approximately giving you a value which is 0.02 farads, because if you round off this to the correct number of decimal places, you're gonna get this. And we are supposed to calculate the charge in the capacitor, and the charge stored in the capacitor is going to be equals to capacitance times the voltage, which means when it's fully charged, what is the current? The current is this when it's fully charged, and also the resistance is 5.1. Then we can be able to work out the voltage when it's fully charged is 12.24 volts. Then once you have gotten that, you can now come here and employ this formula by capacitance times voltage, and then this is going to be 0.0178 times 12.4, because already we had gotten the capacitance from the previous question. That's why we are doing that. And well, if you work out, you are going to get 0.22 coulombs, and that is going to be the charge when fully charged. And you are supposed to work out the energy stored, and energy stored is going to be given by the formula I have QV. So energy stored is the amount of charge times the voltage, and that's going to be 1.3 joules of energy. Question number 3, we are told a train, the model railway is powered. A train on a model railway is powered by contact with the rails, and the train sometimes loses contact with the rails, and the diagram shows the circuit that can maintain and mitigate that loss of contact. And the point here is when it loses contact, this switch is going to be open, and when it's opened, the power supply cannot come from the battery, but it's going to be supplied by the capacitor, because capacitor stores charge, and it can be able to release that charge within a very short period of time, and hence giving a lot of power. Then we are supposed to explain how the circuit maintains the power to the electronics. So we understand when the toy car is in contact with the rail, what's going to happen is that the train, the battery is going to supply power to the electronic controller. When it's off the train, when it loses contact, the switch opens, and then you are going to realize that the capacitor is going to discharge at that given point. When the capacitor is discharging, is going to be supplying power into this electronic controller. That's basically how this circuit is going to work. The next part here, we are told that calculate the time taken for the potential difference across the capacitor to decrease to 4.0, decrease to 4.0, but V naught is 12 volts. So how long does it take to decrease to 4.0? And also something that you need to check is that we are given the resistance here and we are given the capacitance, so which means we are going to apply this particular formula. Voltage is remaining is equal to the original voltage times the E raised to power over raised to the exponent of t negative t over RC. Yeah, so we have the resistance here is 470, capacitance is 47 millifarads, so meaning this is going to be multiplied to 10 raised to power negative 3. And then if you rearrange this formula, guys, you are going to have time to be RC into ln V naught minus L of V. Then if you substitute the resistance and the capacitance, which is provided here, and the voltage, original voltage was 12 minus the voltage that they are asking at this given point, the duration time that is going to be taken is going to be approximately 24 seconds. Yeah, so they are also asking to graph and sketch how the current is going to behave 0 to 20 seconds. So up to it switched closed for 20 seconds. If it's closed for 20 seconds, current is going to be constant throughout, but the moment it's open, then it's going to discharge in that period of time. Well, in this paper, you'll also be asked question which test whether you know how to work out question to do to multiple choices, and usually this is the area that you can easily get marks. We're told that the potential difference across a capacitor or capacitance C, the charge stored is Q. So we have voltage V and C, charge stored is CV, right? Then the capacitor is replaced with two capacitors, each of capacitance to C. So meaning that you have to get the total capacitance in this circuit, which means that total capacitance is going to be the sum of the two capacitors. When capacitors are connected in parallel, you are going to add the two to get the total capacitance. And then for you to work out the total charge is going to be C capacitance, which is 4 farads, yeah, in this case 4 farads times the voltage, which is V, and that's going to translate to 4 CV. Yeah, you can see now this becomes 4 C times V becomes 4 CV, but from this part here, charge is equals to CV. CV can be replaced with Q, and then that's why our answer should be denoted as D. The correct answer for that case becomes D. The student investigating capacitor said the circuit as shown below. Yeah, so those guys who asked me to do Edexcel, capacitance, charge, I believe now you are enjoying this. Give a reason why the circuit did not operate as intended. The student planned to use the circuit to measure potential difference across the capacitor, but you see, as it was charged, so when it's being charged, this should be connected here, right? So as it's being charged, this is disconnected, yeah, so which means when it's charging, the voltage is not across C, so it will not be able to measure, so that's why it failed, right? And when it's discharging, yeah, when it's discharging, when this is connected on the other end here, when this is connected here, it means the resistor will not be in connection. So ideally the student could have connected the resistor at this point and then connect the voltmeter somewhere here in order for it to function as intended. So basically that's what the student could have done. Then the student moves the switch to position X. To position X means now it's going to be charging